Well, we got our final study guide today, so
Okay, good. Is there stuff you
I
can
think
verbalize?
huh?
Is there stuff you can verbalize?
Yes,
Okay.
there's plenty. Let's see where we should start. We got some stuff here, about finding the equation of parabolas given the focus and the directrix.
Okay.
The first one here is find the equation of a parabola with a focus at 4, 3, and directrix y equals 5.
Okay. First of all, what's the general equation? Well, let's figure out whether this is a vertical or horizontal parabola. If the focus, or the directrix rather, is right there, do we have a vertical or do we have a horizontal parabola?
Vertical.
Correct. Not only that, but we know it opens down like that, because the directrix is always outside of the parabola.
Right.
Okay, so this fits the general format that you've been taught for 2 or 3 years, that format right there. But when you're talking conic sections, that format is a little different. When you're talking vertical parabolas, then the format, and tell me, your school actually might do it a little differently. That's the general format.
Yeah, we do it a little differently. I think it's y equals 1 over 2p times x
All right.
minus 8
In
squared.
other words, this is actually, the way you do it is the way I prefer. In other words, all through algebra, you learn this format.
Right.
Okay? And the moment you start studying conic sections, well, there's a lot more to parabolas than we knew about. There was the focus, there's the directrix, and I think A is equal to 1 over 4p. So you could leave it in this format as long as you told everybody that. But here in Colorado, they actually put it in this format here. And I guess there must be a plus k also. So let me think about this for a moment. It doesn't really matter which format you use as long as you know which one you're using.
Right.
So the directrix being y equal 5 tells you what is the coordinates of that point right there.
0, 2.5.
Well, we know the focus is at 4, 3. So actually, I can redraw this thing. Let's draw it properly. Four, 3. So we have a focus that's somewhere like that.
Right.
The one thing we know is that the directrix is the same distance from the vertex as the focus is. Okay, so if the focus is at 4, 3, where is the vertex?
4 comma 4.
Well, if the directrix is at y equal 5, the vertex has to be halfway between the focus and the directrix, so it must be at 4.5.
Oh, okay.
Okay, so let me draw this thing a little bit more accurately. Now we have the parabola that has a vertex at 4.5, 3, has a focus at 4 comma 3, and has a directrix outside the parabola, which it always is, at y equal 5. And their question is what is the equation of this parabola, right?
Right.
Okay. Well, we know where the vertex is, and this is basically vertex. I'll even do it the way you guys do it, which is I like better anyway. You probably maintain the same equation. So the first thing I can do is fill in for h and k, right?
Right.
So I have this. So I know that much about the equation. So now the only thing I have to solve for is a. Well, in my world of mathematics, a is equal to 1 over 4p, with p being the distance from the vertex to the focus.
Right.
Well, I can see that that distance is 1/2. And in fact, it's minus 1/2. So a is equal to 1 over minus 2. So now I have the equation of the line. Y equals minus 1/2, that's a, times x minus 4 squared plus 3.
Okay.
Now, just as a check, let's make sure that our vertex fits that point. Well, when my vertex has an x-coordinate of 4, this whole thing goes to 0, and my y-coordinate is 3. So it definitely fits the vertex. Now, there's some other points we could check, but we really don't need to. In your orientation, this is the most important thing to remember right there.
Okay.
A is equal to 1 over 4p, where p is the distance from the vertex to the focus, which is, in this case, 1/2.
Right.
The fact that it's negative, you'd be able to figure that out anyway, because you're looking at an upside down parabola, so you know a has to be negative. So even if you used plus 1/2, you would still come up with an a of 1/2, and you would realize that it has to be negative because this parabola is pointing down.
Okay.
All right, what else?
Let's see.
Parabolas, incidentally, of the conic sections, parabolas are the hardest.
Yeah.
Circles are the easiest. Ellipses are the second easiest. Parabolas are probably the third, and then hyperbolas are the fourth. Hardest in terms of understanding them.
Right.
Parabolas are difficult only because they kind of totally change. In other words, the very first time you learn parabolas is in Algebra 1, where you learn y equal x squared. And, you know, they don't talk about focus. They don't talk about directrix. It's only when you get to pre-calculus or Algebra 2 honors that they start talking about parabolas in terms of conic sections. And that's when they introduce a focus and a directrix that you have to worry about. And that's what kind of makes it confusing, because they can change the format that you originally learned. What have you covered so far besides parabolas? Have you covered circles and ellipses?
We've done circles. We have not done ellipses.
Okay. What's the standard format for a circle?
X minus h squared plus y minus k squared equals the radius squared.
Those are pretty straightforward. And the reason they are is because there's only one focus, and that's at the center. When you get into ellipses, it's very similar, but there's this a squared and b squared that come into play, where a and b are, that's a, that's b. You can almost think of it as a major radius and a minor radius.
Okay.
Okay? And that definitely elevates the degree of difficulty substantially.
Yeah.
But if you haven't got there yet, let's not worry about that.
Okay.
So, in other words, you're telling me that you've learned that, and that's a circle. And for a parabola, you've probably learned two different things. One would be y equals a times x minus h squared plus k. But you've also probably learned about horizontal parabolas, right?
Right.
That's a horizontal parabola. In other words, this is either like this or like that, but this is like that or like that.
Right.
And
We didn't do a lot.
Notice one thing about a horizontal parabola is it is not a function.
Right.
Nor is a circle. Does not pass the vertical line test. Well, a vertical parabola is a function, but a horizontal one is not. So they don't tend to teach you about the horizontal parabolas until you get into conic sections. And then you kind of learn about them. But obviously in a horizontal parabola, the directrix is still outside the parabola, but it's a vertical line, not a horizontal line. And your focus is always inside the parabola. Okay, what else you got in the way of specific problems?
Well, there was these ones where you had to solve systems of quadratic and linear equations.
Okay.
Like y equals 2x minus 13 and y equals x squared minus 6x plus 3.
Okay. When you have a system of two equations and two unknowns, and both equations are in terms of one variable, the easiest way to solve it is to set this equal to that. Because they're both equal to y. If they're both equal to y, then they must be equal to each other. And now solve that quadratic. What's the next step in solving this quadratic?
Don't think we can factor it.
Well, first of all, in order to consider whether we can factor it or not, we need to get everything on one side and 0 on the other.
Oh, okay.
It's only if 0 is on one side that factoring will do any good.
Right.
In other words, if I have a times b equals 3, I don't care. I can't solve that. But if I have a times b equals 0, I can solve that. Either a or b has to be 0. So
right.
This concept of having 0 on the other side is very important. Okay, so when we do that, we end up with no, good. I'm glad it wasn't that, because that doesn't factor nicely. They do my math correct? I think so.
So that one does factor.
This one does factor easily. I mean, they all factor, but sometimes you have to use the quadratic formula. Sometimes you can factor them into linear factors. This factors into what?
X minus 4, x minus 4.
So the solution to this problem is
4.
though that is the 0. Okay? And the fact that I only have one 0 tells me that the parabola is going to come down and kiss the x-axis and go back up.
Okay.
Otherwise, if it were to go through the x-axis, I would have two zeros. It's very rare to have precisely 1 0. The only way you can get it is if it comes down and, in other words, the x-axis is tangent to that parabola. Now, if it doesn't hit the x-axis at all, let's say it's a parabola like that, then that means it does not have any real zeros. Both zeros are imaginary. When you have imaginary zeros, you do not cross the x-axis. If my parabola looks like this, I got two zeros. I got one there, and they're both real.
Right.
So you really have three situations. You can have a parabola that doesn't cross the x-axis, you can have one that crosses it in two places, and you can have one that only touches it. Well, when you come up with one solution and one solution only, you're looking at this situation.
Right.
And I know it opens up because positive coefficient in front of the x squared term doesn't open down. And I know it touches the x-axis at x equal 4. So I know exactly what that thing looks like.
There was, we also had ones where it was like a circle and a parabola.
Okay? What are the two equations?
Y equals x squared minus 2. And x squared plus y squared equals 4.
Okay, there's the circle. And there's the parabola. Okay? And let's draw the circle. It's right there. The parabola is my standard parabola shifted down by 2 units. So it's like that. So, in fact, 2 units down puts it right here, doesn't it?
Yeah.
So there are actually going to be 3 points of intersection here. So how do we solve for those 3 points?
You have to solve the system.
Okay. It's the easiest way to solve this system.
You could eliminate the x squareds.
Well, you got 2 choices, right? You got elimination and you got substitution.
Right.
When we have one of the equations fully defined as one variable, like we do there, then I think substitution is the easier.
Okay.
Because I can go straight into that equation and substitute for y. So let's do that. We got x squared plus, instead of y squared, I'm going to write x squared minus 2 squared equals 4. And now I can solve that equation. That's one equation, one variable. And that will give me all 3 of these points.
Okay.
Now, it's not the easiest equation to solve. First of all, we get x squared plus, let's expand that, becomes x to the 4th minus 4x squared plus 4 equals 4. So now I can cross that out with that. And I end up with what? X to the 4th plus x to the 4th minus 3x squared equals 0. What's the next step in solving this?
Not sure.
Factor, always factoring. Whenever you have 0 on one side of the equation, the answer is going to be factoring. And I'll tell you why. In other words, if I have one quantity minus another quantity and it's equal to 0, that does not help me. I cannot solve that. If I have one quantity times another quantity and it's equal to 0, I can solve that. You can't multiply 2 things together and get 0 unless one of them is 0. So instead of this expression where I have this thing minus this thing, I'm going to factor out an x squared. And what do I have left? X squared minus 3. Notice I didn't change it. And every time you do a factoring, that's what you should always be looking at. Make sure you don't change it when you go from there to there.
Okay.
Okay, and notice if I multiply this back together, I get x to the 4th minus 3x squared. Okay?
Right.
Now, that allows me to solve it because now I can say either that equals 0 or this equals 0. Has to be. I can't multiply that times that and get 0 unless one of them is 0. So I'm going to set each one equal to 0 and solve. So there's one solution. The other solution is x squared minus 3 equals 0. That means x squared equals 3. What's x equal to?
The square root of 3.
Plus or minus the square root of 3.
Oh, right.
And 90% of my students leave off the plus or minus. It's probably the most common mistake made in algebra.
Yeah.
The only thing I can suggest is that whenever you solve an equation by taking the square root of both sides, which is what we did here, always begin your answer with the words plus or minus. Always.
Right, okay.
I wish they had a song You know, like they do for the quadratic formula? I mean, I don't know if you ever learned a song for the quadratic
Yeah,
formula, but
yeah,
they
we
do
did.
teach it. And the reason they teach it is the same reason they teach a song when you learn your ABCs. A, B, C, D, E, F, G. It makes it easier to remember. So I wish I had a song to teach this because everybody makes this mistake. Now, there is one reason that you should not have made that mistake. That's because I know that there are three solutions from my picture. Well, this one is x equals 0. This one is x equal square root of 3. And this one is x equal negative square root of 3. So when I look at my model, my picture, I'm looking for three solutions. I know that there are going to be three solutions. Well, if I don't
Right.
put a plus or minus on that, I only get two solutions. I get x equals 0 and x equals square root of 3. So that should be a clue that you've made a mistake when you only come up with two solutions. So that's kind of one advantage in drawing a picture, is that you can see exactly how many solutions you're going to have. Now, how
Right.
did I know that this point was the same for the parabola and the circle? Well, the circle clearly has a radius of 2, so this has to be at minus 2. And the parabola has been shifted down by 2. So the vertex has to be at that same spot. And that being the case, there must be a total of 3 points of intersection.
Okay. We had one more with these systems, and it's
Okay.
two circles intersecting each other.
Okay?
Let's see. X squared plus y squared equals 5. And quantity of x minus 2 squared plus the quantity of y minus 1 squared equals 3.
Here's the first circle, radius of 5. Second circle has a center of there and a smaller radius. Whoops, hold on. Something like that. So how many points of intersection are we looking at?
2.
Okay. So we know we're searching for that and that. How are we going to find those?
Solve the system.
Right. Okay, well, first thing, I can't think of an easier way to do it than to go ahead and let's distribute that. So when you square that term, what do you get?
X squared minus 4x equals 4.
Plus 4.
Or plus 4.
Square this term.
Y squared minus 2y plus 1.
Now, always remember, you don't want to change anything. That's exactly the same as that. Okay? I haven't done anything special. I haven't squared both sides or anything like that. As all I've done is distribute that.
Right.
Okay? Now, let's simplify these numbers. If I've got plus 4 plus 1, that's plus 5. Let's move that to the other side and make that a minus 2. Okay?
Right.
And let's run a line through that. Because the way we're going to solve this system of equations now is to if I subtract this equation from this equation, I get 8x plus 4y, no, I just get 4x plus 2y equals 7. Which has an infinite number of solutions.
Right.
Interesting problem. I haven't done one like this in a while. Wow, how are we going to solve this? Two circles that intersect. I know this distance. I mean, I can figure that out because that point is 2, 1. I don't know. It's not coming to me. You would think that I would have come across this problem at least once in 7 years, where you have the equation of two circles, where are their intersection points, and the only thing I can see is you end up with one equation and two variables.
Yeah.
This equation right here, and that can't be solved. When you have one equation and two variables, you basically have an infinite number of points. So what am I doing wrong here?
Is there a way we could use that first equation?
X squared plus y squared equals 5? Well, see, that's what I've done. Once I've converted this to this, the two equations that I have check marked, is all I did was I subtracted. If this is equation 2 and this is equation 1, I subtracted 2 from 1.
Right.
And I got rid of the x squared and the y squared. And it left me with 4x plus 2y equals 7. Now I need another equation. What other equation can I come up with for x and y to solve this? I can't think of one. Let me think for a second. What do we know about these two circles? We know one has a center at the origin. The other has a center at 2, 1 with a radius of 3. So this distance to that intersection point has to be 3 no matter what. Well, that actually might give me my second equation. In other words, the distance between there and there.
Okay.
Use the distance formula. The distance formula says it's the square root of the x-coordinate minus the x-coordinate squared plus the y-coordinate minus its y-coordinate squared. And I know that distance to be 3, because the radius of that circle is 3. So there's my second equation.
Okay.
And if I square both sides of this equation, I eliminate the square root sign, turn that into a 9. This isn't going to help. This is the same equation as this. It's the equation of the circle, is it not? Maybe not. Yeah, no, that's the original equation I started with. That's this equation here, using the distance formula, oddly enough.
Well, I guess it's possible this could be a mistake.
No, I don't think it is. I'm just not sure how you find the points of intersection between two circles. Because it seems to me you're always going to come down. Did I make a mistake in math here? I'm wondering if I did, because this doesn't.
I don't think so.
That's definitely the equation of the circle at the origin. And that's the equation of the circle whose center is at 2, 1. And their intersection point is going to occur where x is equal to x and y is equal to y. In other words, normally when you have a system of two equations and you want to find the intersection point, you solve it as a system of equations, which is what I did. But when I solve it, I get only one equation left over, and it has two variables in it.
I guess we could skip this one for now.
Let's do that, just so we don't waste your entire session on me trying to figure this out.
Okay.
If I happen to come up with the solution after thinking about this, which is usually what happens after about 15 minutes after our session, I will email you or send you a text or something.
Okay.
But at the moment, I can't immediately figure out how we're going to solve this. No, I don't know. I'm going to leave it there just so I can see it. What do you got next?
Let's see. We've got some factoring things here.
Okay.
Let's see, I think I know how to do this, but let's just go over it. Negative 3x squared plus 9.
Just that expression we're going to factor?
Yeah.
Okay. Always start your factoring problems with greatest common factor.
Right.
Is there a greatest common factor I can take out of that?
Negative 3.
What's it leave behind?
X squared minus 3.
Okay. Now, you've learned something called difference of perfect squares.
Right.
But it doesn't always have to be perfect squares. I don't know. This may be the answer your teacher's looking for, but I like to think of that as difference of squares. I know how to factor that. That factors in the following manner. x minus root 3 and x plus root 3. Notice that it factored even though I did not have difference of perfect squares, I just had difference of squares.
Right.
So this may be the answer that you're looking for, or if they haven't yet worked into difference of squares, this might be the answer.
I think the second one's probably what he's looking for.
Yeah. In other words, I'm not sure why they ever teach it as difference of perfect squares. I guess they're always looking for stuff like this or stuff like this, where both terms are difference of perfect squares, something like that. That makes it easier to understand if we call that difference of perfect squares. But
Yeah.
certainly that factors into those two factors, and 3 is not a perfect square number. But it still factors into square root of 3.
Right.
It's just a question of at what point in algebra that they teach you that. It becomes more significant when you get into calculus, where you really do need to factor something like that. That's why I wasn't sure what your final answer was going to be.
And let's see. We also have factoring a cubic by grouping, which
Okay.
I think I know how to do. We have 3x cubed minus 12x cubed, or 12x squared plus 2x minus 8.
Okay. Now, the first thing you should understand is that grouping is only going to work for about 1% of your cubics. If I change that to a 7, I cannot solve this by grouping. The only reason grouping works is because the ratio of 3 to minus 12 is the same as the ratio of 2 to minus 8. Whenever the ratio of that coefficient to that coefficient is the same as that coefficient to that coefficient, then you can solve it by grouping. And the way I do it is by separating those two terms and those two terms, making sure we leave that plus sign in front. In other words, I group it. Now, from this group, what can you factor out? What's the greatest common factor?
3x squared.
Leaving
X minus 4.
What's the greatest common factor over here?
2.
Leaving
X minus 4.
Now, as long as that is the same as that, I can factor an x minus 4 out. Okay? And this is the only difficulty with grouping, is that up till now in your algebra career, you've only factored out monomial terms. It's not that common that you come across an expression where you can factor out a binomial term. That is a binomial term. But the fact of the matter is that factoring is merely dividing every term by your factor. So I can factor out the x minus 4 as a quantity, leaving what?
3x squared plus 2.
And I've solved it. Now, if I want to fully factor it, I've got to apply the quadratic formula to that. Because this part of it's going to produce two imaginary solutions. And I know that because that's always positive, and I'm adding a positive number to it, So there's no way that this expression over here can ever be equal to 0. Since it can't be equal to 0, it's got to be imaginary solutions.
Right.
So if they wanted you to fully factor this, then you have to apply the quadratic formula to that part of it.
I'm not sure if he wants us to do that.
You don't know if he wants you to do that? Well, let me just make sure that you know how to do it if he did.
Okay.
What's minus, in other words, the quadratic formula is this. Because it's a little strange when you express that imaginary solution as a linear factor. What's minus b?
0?
Huh? So we have plus or minus the square root of 24 all over 6, which is plus or minus 2 root 6 over 6, which is plus or minus root 6 over 3. Excuse me, there's a minus in there, which means there's an I. So actually, my two imaginary solutions are plus root 6 over 3I and minus root 6 over 3 times I. You do that, first of all?
Yeah.
Okay, well, let's erase all of that and go back to where we're listing our linear factors. Well, remember the linear factor is always x minus the root. So we still have our x minus 4. But now I'm going to split that up into x minus root 6 over 3I and x plus root 6 over 3I. And there are your three factors of that cubic. Two imaginary, one real.
Okay.
The only thing I was trying to point out is that when you do come up with an imaginary solution, it's still x minus whatever that solution is.
Right. As
a factor. Okay. So sometimes, in other words, in our particular situation, we did not have a number in front. But let's just, for the sake of argument, say that we came up with 2 plus 3I. And this one would be 2 minus 3I. Well, now this factor is going to be x minus the quantity 2 plus 3I. This factor is going to be x minus the quantity 2 minus 3I. So even if you have a complex solution that has a real part to it, you still have to do x minus that whole thing.
Okay.
Okay. In our situation, we only had the imaginary part. In other words, that was our answer, plus or minus. So we didn't have any real part to that. So it made it look a little easier. We just had x minus the imaginary part. But if there is a real part, you have to do x minus the whole thing.
Okay.
All right. What else? We got 7 minutes. What can we do in 7 minutes?
Simplifying rational expressions.
Okay.
D. 2 times the quantity of x plus 1 plus 2 over the quantity of 2x plus 3 times the quantity of x plus 1 minus 1.
Like that?
Yeah.
You sure I've written it exactly the way it is on your paper?
Yes.
Okay. Well, notice, first of all, I cannot cross out the x plus 1. Because this x plus 1 up here has 2 being added to it. This x plus 1 down here has 1 being subtracted from it. So I cannot make that cancellation. However, let me distribute everything and see what I get. Well, this becomes 2x plus 2 plus 2, so this becomes 2x plus 4. This becomes 2x squared plus 5x plus 3 minus 1, which means plus 2. Now that factors, let's factor the numerator, which is 2 times x plus 2. This denominator actually does factor, I believe, into 2x plus 1 times x plus 2. No. Yes. Gives you the correct middle term. You with me?
Yeah.
Now I can cross off the x plus 2's. And I end up with 2 over 2x plus 1. There's my final answer. And I cannot simplify that.
Right.
So the secret to this was just carrying out the multiplication and addition to simplify the numerator and the denominator, and then seeing if you could factor the denominator, which we were able to.
Yeah, that's the part I usually get confused on, is with a denominator like that.
This is a tricky problem. I don't see problems like this very often. But that's not the first time. You've given me a few problems I've never seen before.
Yeah.
I guess when you see something like this, you know that you really can't do much with that until you multiply that times that.
Okay.
And combine it with that number. And then hopefully you have a quadratic that factors. In other words, they're not going to give you a problem like this unless that's true. In other words, if I ended up with a quadratic that did not factor and I couldn't cancel anything, well, then I can't do anything with the problem. So you almost have to proceed under the assumption that you're going to end up with a quadratic that you can factor.
Right.
And in fact, once I factor it, I see I have the same factor in the numerator as I have in the denominator, and now I can make a lot of progress by canceling.
Right. How exactly did you go about factoring the denominator? The 2x squared plus 5x plus 2?
Well, let's talk about that briefly. This is slightly harder than a typical factoring problem merely because this coefficient's not 1. So the way I factor everything is I start by splitting that up. Well, that can only be split up in that manner.
Right.
Next, I determine both signs. Both signs have to be positive. Next, I know that the numbers that go here have to be factors of 2. And if I'm to produce a middle term of 5, it's got to be that and not that. In other words, 2 and 1 produce a middle term of 4, but 1 and 2 produce a middle term of 5, which is what we have.
Okay.
However, there is another clue to use, and that is that we know we're going to end up with an x plus 2 in the numerator, right?
Right.
So we would expect one of those factors to be x plus 2.
Okay.
And that's a pretty good clue. If I know that one of the factors is x plus 2, well, then the other one has to be 2x plus 1. And then you see that that does indeed produce a middle term of 5x.
Okay.
But when you see problems like this, always know that, wow, they wouldn't have given you this problem if I don't end up with a factor in the numerator and the denominator that's the same.
Yeah.
Because otherwise, why would they give me the problem? I can't, in other words, if this ended up being that, 2x squared plus 5x plus 3, I can't make any progress on it. That's the final answer. So
Right.
it wouldn't have given it to me as a problem.
Okay.
All right. You good to go, Chris?
Yeah, I think, that's pretty much what I was confused on.
Okay. I just want to warn you that next week is going to fill up very fast.
Okay.
So I've got openings now, but if you wait 2 or 3 days, you might not find anything.
Okay. I don't think I'll need another one.
When's your final?
Thursday, I think.
Okay. That's fine. I hope you don't need another one, but if you do, make it early.
Okay.
And if you don't see anything available, feel free to call me. Sometimes I'll block out an area and I might still have some availability even if it doesn't show on my schedule.
Okay.
All right?
Well, I will make that decision today, probably.
Okay. Have a good weekend, Chris.
Thanks, you too.
I'll talk to you later. Bye-bye.
Bye.